So we are going to start Geometry Notes, Chapter 1, Section 1, 1.1, identifying points, lines, and planes. Now, as you can start here, you can see there is a lot of vocab. One thing I want you to know in geometry is I do not have vocabulary quizzes. I do not have big matching sections. You don't have to know formal definitions for all these words. For me, many times, I will tell you that it's more important to just know what the word is for. If you can more easily define a word by a picture, please draw a picture for it, if that's what makes more sense to you. Now, does that mean the vocabulary is not important? Not at all. Vocabulary in geometry is super important, but the important thing is that you know and when and what it means. So if I talk about a collinear point or I talk about an opposite ray, as long as you know what it means, then when I ask you to identify one in a picture, you'll be able to do so. So if you go to fill out these vocab words, you have the option of just copying down what I have here on the board. I will tell you many times, because this program where the words show up right away, I may actually go through these faster than you can write them down. Remember, this is a video. Pause it, copy down what you need, write it in your own words, draw a picture. Your notes are for you and to make sure you know what's on them. So write down what you need. I'm going to tell you on this page right away that most of the words I have typed out here for definitions, they're also included in the next few pages of your notes. So it's not as important that you have every little word copied here on the vocab, but more that you listen and understand what it means. So my very first word is called undefined term, words with no formal definition but an agreement about their meaning. If you've ever been in English class and the teacher says, please fill out the definition of these words, I think usually one of the most important things they tell you is you can never use the word in its definition. So that is kind of where this undefined term is. So you'll notice I have 3 stars over here in the margin, beside point, line, and plane. And one of the reasons is it's extremely hard to tell someone what a point is without using the word point. And because of that, that's one of our undefined terms. The same thing with line and plane. So I think most of us know what a point is, but it's really hard to be able to tell somebody, well, what does that mean? Okay? So a point has no dimension and it's represented by a dot, and we often will call it a name. Okay? We'll often have a symbol beside it so I can tell you where to look. So if I tell you to look at this point, you know where. Okay? And then a line, which I think I threw this on your pretest for those of you that took the pretest. It's one dimension, and it's represented by a line with 2 arrowheads, and it goes on and on and on forever without end, okay? And often, again, we will have some points on that line to help identify that line. A plane is 2-dimensional, represented by a shape like a box that extends without end in 4 directions. Technically, I should be drawing this with all these arrows because it goes on and on, up and down. It goes on and on, left and right. So this box is going to go on over and over, on and on and on, and never stops if it's a true plane. As you can see right now, that picture is getting pretty complicated. So often in geometry, we will leave the extra line and arrows off, but just know that a plane should go on and on and on. Example of a plane for you would be like the front chalkboard, okay? Obviously, my chalkboard ends, but it could go on and on and on in that flat surface and keep touching things. Okay, next word, collinear points. Some English lesson here, right? Co is a prefix. If you have a co-worker, that's someone who works with you, okay? So colin or line-ear, right, means together on the same line, okay? So these are points that are together on the same line. Collinear, collinear, okay? So then we get the same thing. So if I have a line and I have points on that same line, okay? That means points A, B, and C are collinear. Coplanar means I have this big flat surface, and on my flat surface I have more than one point, and those points are coplanar because they're on the same plane. Okay, defined terms, terms described using known words. So all the rest of these are defined terms. This, again, not something you're going to get a vocab thing on, but just kind of to tell you that sometimes it's really hard, even in math, to have exact definitions and such. Okay, a line segment. Once again, if I was telling you to fill out this vocab, I would tell you to draw a picture, okay? It's a line segment has exactly 2 endpoints, and then it's all the space in between this line, okay? A ray has 1 endpoint, and then it extends in one direction. And I'm going to be honest, think of it as a sun ray. Here's the sun, here's a ray, here's a ray, here's a ray, here's a ray, here's a ray. They all start at one point and they go off in a direction. That's what a ray does, okay? Now, we have lines, we have line segments, and we have rays, okay? There is a difference between them, and it's going to be one of your jobs to know the difference between them and to know what kind of properties we can find from those. And we'll learn more on the next page about those. Opposite rays, rays that share the same endpoint and are collinear. Now, a picture really does help, but if I just draw the picture and you just see a picture, it might not. So here's a ray. I'm going to have this ray go this direction, okay? I'm going to change colors so if somebody's looking at these notes, maybe it'll make more sense later. My ray that shares the same endpoint, so it still goes to this endpoint, and are collinear on the same line, so this ray is going to go like this. So together, they look like they make one long line, but they're actually opposite rays. They start at the same place and go in exactly opposite directions, so it's an opposite ray. And the last word here is an intersection, the set of points figures have in common. So where they meet, what they share, okay? That's an intersection. And again, sometimes you can think of just 2 roads. When they meet, that's an intersection, right? And we can intersect in points and such. We'll cover this more on that last page. All right, so let's move to page 2. See what we have. All right, on page 2, one of the most important things here is that you understand the difference between a point, a line, a plane, a ray, a line segment, all these things, and how to name them. So you're often going to be writing on a homework, on a quiz or a test, the name of something. And if you don't properly name it, I don't know that you're talking about the correct thing. So what the big idea is you need to get out of this lesson today is naming things correctly. Okay, so you'll notice I have all these little notes in the margins already copied into your notes and such. One thing you're going to learn is that if I put something in the margin, it's probably something that wasn't super clear from the textbook, or it's super important to me and I feel you really need to know it. So make sure you carefully pay attention to all of the stuff I put in the margin, okay? So the first thing I have is a point. And a point has 0 dimensions, meaning there's no length, there's no width, there's no height. There's just 0 dimensions, and it's represented by a dot, okay? Your job is, can you name a point? So if I give you this like this, and I said, here's a point, and I say, what's the name of that point? This is your job. You have to write down the word point, and you can't put a symbol there. You have to write the word point, and then the symbol behind it. So this would be called point pi. Okay, so over here you'll notice they called this one point A. They spell out the word point, and you have to do that, and then you put whatever symbol is behind it. If you don't write the word point, you're going to lose a point on your quiz or test, so make sure you write the word point. All right, then we're going to move on to a line. A line has 1 dimension. It's the kind of the length or whatever. It's represented by a line. Notice how we use the word in its definition. With 2 arrowheads, but it extends without end. Okay? So we have 2 points. We have a line, goes on and on and on, okay? I'm going to throw one more point on here just to kind of prove a point. All right, here's a rule, and this rule is super, 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 super important. Through any 2 points, there's exactly 1 line, and you can use any 2 points on the line to name it. Okay, it does not matter where your 2 points are. If you have 2 points, you can join them with a line. So if I said one of your points is Ida and one of your points is Dundee, you can draw a line between those. There is 1 line that you can make go straight from Ida to straight to Dundee. If I say I need a line between Mr. Morelli's room and the cafeteria, you could draw 1 straight line between Mr. Morelli's room and the cafeteria. It doesn't matter where those 2 points are. Through any 2 points, you can always make 1 line. Okay, so keep that in mind. And we name a line with 2 of the points. So there's many ways we can do this. We can use the word line. So I could write down line, and then I need 2 points. I could call this RS. I only use 2 points. I don't use 3 points. I don't use 4 points. I only use 2 points, okay, to name it. So line RS. That's one way. I could use just R and S, and I could put a symbol above it with the arrows. So line RS. That's fine, okay? That's another way to do it. Now, I could have named the same line, line ST, and I can write it like that. So it doesn't matter how many points are on the line, you use always 2 and only 2 to name it. There's one exception. If you look over here on their line they drew over here, do you see this little cursive L? That cursive L does not have a point to go with it. And I should make sure I kind of erase this so you can see that. That L is just hanging out there, and it's cursive, and it's all by itself. Because of that, you can call it line L, only because it's not a point. But if you use points on the line, you must use 2 points. All right. A plane. A plane has 2 dimensions, okay? It has like a length and a height type thing, or a length and a width, okay? It's represented by a shape that looks like a floor or a wall, but it extends without end forever, okay? Through any 3 points not on the same line, that's important, there is exactly 1 plane. And you can use 3 points that are not on the same line to name the plane, okay? Now, let me draw you a plane here. So here's my plane. When I go to name a plane, I have to write the word plane all the way out, P-L-A-N-E, which, okay, plane. And you have 2 options from there. You can either use a letter that is not a point, so I can call this plane X, or I can name a plane with 3 points that are not on the same line. T, W, Z. It doesn't have to be in alphabetical order. It can be mixed up as long as it's 3 points. Okay. Now, there's something I would need to tell you because some kids get confused on this. You have to use 3 points and only 3 points, and they cannot be in the same line, okay? So, careful here. T and W. Can I draw a line between T and W? Yes. So, I have 2 points right now that are on the same line. But as soon as I add Z, Z is completely off from the other 2. Now I have 3 points not on the same line. 2 of them will always be on the same line. So don't worry if 2 of them come from the same line. The third one needs to be off that line. And as long as the third one's off that line, it defines a plane. Okay? Once again, this is super important, and you're going to see questions on your homework, on your next quiz and stuff that say this. I'm going to ask you, are these 3 points, do they make a plane? Okay? So if you see 3 points not on the same line, I don't care if they're in Timbuktu, Kalamazoo, and one in Ida. If they're 3 points not exactly in the same exact line, it will form a plane, okay? So if you can see 3 points not in the same line, yes, you can create a plane, no matter if you can see the plane or not, okay? All right, so let's go ahead and do some examples down here so you kind of see where we're going with this. Okay, so we're using our rules from up above to name it, and it's so important that we name them correctly. So the first thing it says is look on this diagram, and just so you know, this is a 3-dimensional diagram. This plane right here, kind of think of it as a piece of paper, okay? This line is drawn right on top of the piece of paper, but this line, with it, when you see it sticking up like this and then you notice these dashed lines, that's like a pencil sticking through the paper going up and down in a different direction, okay? So it's 3-dimensional. They're not all going the same direction. Okay, so let me get that a little clearer and let's go answer. So the first thing we're going to do is look at line LN, which is right here, and try to give some other names for it, okay? So when we name our line, we can write out the word line, and we can use that little B because it's not a point. Or we can use 2 points on the line. Now, line LN is good. By the way, you can flip it and call it NL, and it's still the same line. I also see a point M right there, so I could call it ML, or LM, or MN, or NM. So there's many ways I could name that same line, and it's always talking about that exact same line, okay? So now I'm going to switch and I'm going to do, they asked me to name another plane for plane Z. So notice that that Z is not a point. It's just sitting in the corner by itself. That's the only way you can use plane and one letter. All the rest of the time you need to say plane with 3 letters not on the same line. So just a hint, I cannot go LMN because that's on the same line. But I could say LMP because they're not on the same line. So plane LMP. Or I could write the word plane, and I could say NNLP, okay? Again, order of the letters doesn't matter as long as the 3 letters, there's always 3 for a plane, and they're not coming from the same line. All right, next question here, and I'm going to clear my marks from my picture so that I'm not worried about confusing you if it lets me here. Okay, now I did. It says on B, name 3 points that are collinear. Collinear, your co-workers who work with you, collinear are on the same line. So I'm looking for 3 points on the same line. So it looks like I can do L, M, and N. Points L, M, and N. Notice I wrote a list there. I wrote points once, or the book wrote points, and then L, M, and N. I can just list those, okay? Lie in the same line, so they're collinear. It says name 4 points that are coplanar, on the same plane or the same flat surface. Again, they started with points, and I can't use Z because there's no dot by it, but I can use P, and I can say points L, M, N, and P, okay? So just make sure that they come from the same thing. I want to point out, too, on the coplinear, some people are like, well, what about Q, M, and A? Now, peek at A real carefully. Is A even a line? Or a point, I'm sorry, is A a point? And the answer is no, it's not marked as a point, so don't use Q, M, and A because A is not exactly a point. All right, ugh, struggling here. Okay. It says on number 1 down here on the checkpoint, we're looking at the same picture. Give 2 other names for line MQ. So I look at line MQ and I say, is there another way I can name MQ? So MQ is this kind of this pencil sticking out of my paper coming through. And I just covered it up, but do you see that invisible one? We can say, or not invisible, line A, because it's not a point. That's one way. We could flip those letters around and say QM, okay? You cannot mix M with A or Q with A because points can't mix with the non-points. All right. Now, second question over here. It says, can you name a point that is not coplanar with points L, N, and P? So when I look at that picture, I say, what's not on the same piece of paper or the same flat surface as L, N, and P? Those are all on that paper, that flat surface. What's not? It would be point Q. And remember, you need to use the word point when you name this, okay? Page 3, we're moving on. Maybe. Okay, some more definitions up here, and you'll notice I have some more margin notes. So we've used plane, line, and point. And now we're going to go to segments. So I have the redefined line up here, the type line AB. We can write it as AB with the line above it. And points A and B are used here to define the terms below. So we'll start with a segment. The segment AB or segment AB written as AB, and this time we're going to use a segment above it, no arrows. Consists of the endpoint A and B and all the points on the line that are between A and B. Note that AB can also be written BA, okay? Now, when we name it, we use 2 endpoints and a line above it, no arrows. The order does not matter. So if I tell you, here's my line segment, and I tell you I have an N and an O, I can call that line segment no, and I can call that line segment on, It doesn't matter, it goes either direction. But that's all, okay? If I want that full line segment, and if I happen to throw a point in there, I can't say NM or MO, because those are shorter segments, and I can't do those. I have to stick with just the endpoints, and the endpoints on there, no arrows on the name. Array AB can be written as array AB with an arrow above the B. It consists of the endpoint A and all the points on ray AB that lie on the same side of A as B. Okay, so here's ray AB. It starts here and it goes through B and it keeps going. Okay, it doesn't stop. Starts at A and keeps going through B. But think about it. I can't flip the letters because if I started at B and went through A, are those rays going the same direction? And the answer is no. So AB and BA are different rays. Okay, they are not the same, so order definitely matters, okay? I'm going to draw a line here. And I'm going to draw STRQ. Okay. It says name array and always put the endpoint first. It doesn't matter which direction, okay? I'm going to take from here, I'm going to take my model, and I'm going to call this my ray. This red part is going to be my ray, okay? You always name a ray from its endpoint. So it started here at T. Then I have to name a letter it goes through. Well, it goes through S, and it keeps going through S, so my arrow goes over S. So even though that ray is going down to the left, I still write how we write in English, the first letter of where it starts, and then a letter it goes through, and I make my arrow always go to the right. So when I see your ray names on your paper, it should always have a arrow that goes to the right and only to the right, okay? So the order is super important here. By the way, so I have this other arrow, this other ray over here. Okay, I'll make this one gray. What if I start here from T and go this way? What could I name that ray? Well, it started at T, and it goes through Q, so I can name it that. But I could also name it T and go through R, because it really is the exact same ray. I just have to have the same ending point, and whatever letter it goes through, I name one of those letters. So you could name it different things, but make sure you're naming it in the direction you want it to go. Okay, some examples to do here. Okay, one thing about this picture I want to point out. When I ask students a lot of times, I'll say, look at this picture. How many points are on this picture? And I get a lot of people that tell me 4. But the correct answer is 5. Even though there is no point at W, because they name that W, there has to be a point right there. And by the way, remember on the earlier slide where those little A's and B's, they were cursive, they look different than other things. For the most part in geometry, we're going to name things with capital letters. So when you see those little letters, there's a good chance they're not a point, okay? But that W is a point. Sometimes they leave it off just because they don't want it to get too confusing. So even though you don't see a point at W, there really is a point at W, okay? So let's look here. We have, it says segment VX. So VX goes from V to X, and it's a segment. What's another name for it? Well, there's only one other thing you can name that, and you can flip the letters around and go XV, but you can't do anything else. It says name some rays with endpoint W. So think of W as your sun. Where can it go from there? Well, we can go straight up and go WY. So that means it started at W and went through Y. We can go to W and go through X, so I'm going to go W and go through X. I can start at W and go through Z, WZ. I can start at W and go through V, so WV. All of those are rays that have an endpoint of W or start at W. All right, opposite rays. It says, which of these rays are opposite rays? Now, the reminder there is, think of it as being on the same road, going opposite directions. An opposite ray, I have that reminder here for you in the margin, needs to share the same endpoint, but it needs to go in opposite directions. So if I just start you out and say, I'm going to start with the ray WY, okay? WY is going up. What is its opposite ray? Well, it has to start at the same place, but go exactly opposite direction, so that one's going to be WZ. We have another set. If I choose to say, I'm going to start with WV, well, it started at W, went to V, but it went to the left, so its exact opposite would be WX that goes the other way. So a quick note, notice when we talk about opposite rays, they have to start with the same letter. If they don't start with the same letter, they can't be an opposite ray. All right, cleaning up the picture here so we can use it for our last examples down here on 2 and 3. It said look back up here and let's name another name for segment YW. The only way you can have a second name for a segment is to flip the letters, WY. They ask you, are VX, let me clear this up, are VX, so ray VX starts at V, goes through X, and XV starts at X and goes through V, are those the same ray? So for my first question, I'm going to have to say no. Not this, the order matters, right? The second question says, and let me clean this up again so we can see, is VW, so ray VW, so here it is, and ray VX starts at V and goes through X, are they the same ray? And we can say yes, same endpoint, and same direction. Okay, before we turn the page here, I want to point a couple things out. Lines, segments, rays. They look very similar, there's small differences. If I handed you a ruler and I gave you a line and I gave you a segment and I gave you a ray, can you measure them all? When you think about using a ruler, you always have to put that 0 mark down at the end of the line, the segment, or the ray. Can you find an end to the line where you're going to lay that 0 down at? No. A line goes on and on forever. You are not able to find its end, and you are not able to measure a line. A line is unmeasurable. A line segment, can you measure a line segment? Sure you can, because a line segment has 2 endpoints. You can find the 0 on one endpoint, and the other endpoint will land on a number that you can read on the ruler. So a line segment can be measured. Can you measure a ray? And the answer is no, you can't measure a ray, because a ray has one endpoint where you can lay the 0 on the ruler, but it never ends in the other direction, so you cannot measure a ray, okay? So just keep that in mind, that the only one of those we can measure is a line segment. All right, last page here. All right. Oh, good, I was worried that I couldn't move that. Okay, so a couple things over here I want to state. 2 lines can intersect at one point, okay? So in your margin, I think you have some blanks that you're going to fill in. So I have a line that goes this way and a line that goes this way. So 2 lines, when they intersect, they meet at a point, okay? That makes sense because roads are like lines, they meet at one point if they say straight. And by the way, to say straight line is kind of over redundant, because just like over redundant is over redundant. But a line has to be straight. So yes, all lines should be straight, okay? A line and a plane can intersect at one point or at one line, okay? We have a plane, and I can lay and I can draw a line right on top of that plane. That means that you have this intersection of a full line and the plane. They just keep going on and on and on forever, okay? Or I could have a line that is coming from the top here, and it pokes through the plane and comes out the bottom. So in that case, that line only touches that plane one point, okay? Just one time. All right, 2 planes can intersect at a line. Okay, I'm going to try to draw this, and we're actually going to draw one ourselves in a little bit, but I'll try my best here. So I have one plane here, kind of a piece of paper. I have another plane that's going to go like this. Okay, so these 2 pieces of paper are meeting, and they meet in this line right here. So where they meet is a line right there, okay? Think about it as the front wall and the ceiling. When the front wall and the ceiling meet up there, there's a straight line all the way across where those meet. Or where 2 walls meet, then you have that corner all the way down. That's a line where they meet. Okay, now the hardest one here, and I find this extremely hard, is three planes can intersect at one point or one line, okay? Think about on a box, okay? Here's a box. Where did all three of them meet? Sorry. Right here. All three of them came to corner in that one corner. So that's where all three of those meet in one point, okay? Or three planes can intersect at one line. Now, I'm going to tell you right now, I can't draw this one very well, but I can try to do something here. Think about, I have two walls already, right? And those two walls are meeting right here in this line, okay? If I decide to draw a diagonal wall coming in, okay, it can also meet in this same one, okay? So you think about like cubicles being put together, whatever, you could have multiple planes coming together in one line, okay? That's kind of what you're thinking of. If any of you have ever seen some filters in cars, sometimes when you look at the top of a filter, you see these like thin pieces of paper, like almost that fit together, like almost spokes, and that kind of is multiple planes coming together in one line. All right, sketching. I'm going to have you do some sketching. Don't worry about it. You don't have to be a great artist. If we were great artists, we'd be in the class next door, right? But just do your best. Sketch a plane, okay? When I see that, there's my plane. It's a piece of paper. And a line that intersects the plane at more than one point. Well, if I want to intersect more than one point, I'm going to have to lay on top of it. So that's how my picture's going to look, okay? Now I need to sketch a plane and a line that is in the plane. Okay, so I have a plane, a line that is in the plane. In means right here, all the way across. And I'm going to sketch another line that intersects the line and the plane at one point. So here's one point. I'm going to bring this line down. It's touching it here, but then it's poking through and going all the way through. So are we great three-dimensional drawers? Not great, but it's okay. All right, let's move. And I'm going to sketch two planes that intersect in a line. Okay, I did this earlier, and you can try to draw it with me, see if you can handle this. Draw one plane as if you're facing it. So there's my piece of paper, okay? Now draw a second plane that is more horizontal, is what I'm writing here, okay? Use dashed lines to show where your plane is hidden. So I'm coming out this way. Okay, so this is the front I can see. Then when I make the back, okay, I'm dashing it, then I can see it again. And that's kind of where they intersect. And so if you think about it, they're crossing right there, okay? So that's my line of intersection. Number 4 says sketch two different lines that intersect a plane at different points. So here's my plane. This one came through and touched the plane right here. This one came through and touched the plane right here, okay? It doesn't have to be super complicated, okay? All right, last two, and again, when we name something, one of the most important things is how we name it. Name the intersection of the line MX and line A. So if I look at it, line MX, M's here, X is here, so it looks like it's this line here. Line A is this one here. Where do they intersect at? Where do they touch? Okay? And I've had a lot of people say, well, they intersect at M. What's M? McDonald's? Maryland? M, Midland, what's M? Make sure you say point M, so I know that they only meet at a point. All right, last and final one here. Let me erase so we're not confused. Name the intersection of plane C, that's my gray plane right here, and plane D, which is my white plane right here. Where do they intersect? So it looks like they are meeting right at this point line right here. What can we call that? And what's important is we say it's a line. Now, there's only two identifiers on this line, this little a and this M. M is a point. Little a is not. I can't join a non-point and a point, so I simply have to write the word line and say A. And that's where they meet at. Okay. I'm going to admit, after I get all the way through this, this is one of my least favorite sections to teach. I find it incredibly boring, but we need to learn it. So it is super important that we use this through the rest of the school year, and we use this in geometry. And I'm going to tell you right now that on our first couple quizzes and tests, you might lose points if you don't label something correctly. It is so important that we label things correctly so that others can look at what we wrote and know what we're talking about. So we need to use that word point, P-O-I-N-T, and then say the letter that goes with it. We need to say segment and not put arrows above it, so they know that it stops and we can measure it. It is so important that we name things correctly. Lines, segments, rays are named with 2 letters and always 2 letters. Planes are named with 3 letters and always 3 letters. The only exceptions are if those are little cursive letters that are in the corner that are not points, okay? So, for your homework, and I'd like you to do this, geometry students, and bring this to class with you, on page 5 and 6 in your textbook, try number 1 and number 3 through 22 all. And the most important thing is, are you labeling those correctly? So make sure you're very careful writing your letters and then putting the right lines or points or whatever it needs to be. If you have questions, send me an email. Ask when you come to class. Make sure you are vocal and tell me if you get this or not. Good luck.